Chapter 2.6, Related Rates, Day 3. We will continue going through some practice problems for related rates. You have the concept, you just need to practice it. All right, so we'll start with a review question. A circle's radius grows at a rate of 2 centimeters per minute. How fast does the area grow when the radius is 12 centimeters? Right? First step, draw a picture and write what you know and you don't know. So here I got a circle, we got my radius. We know that the radius grows at a rate of 2 centimeters per minute, so that's dr dt. The change of the radius with respect to time is 2. We know the radius at a certain point is 12 centimeters, and we're looking for how fast the area grows. Well, how fast does the area grow? That's dA dt, and that is our unknown. Now we write an equation that relates those variables. We got area, we got radius. Our equation, area equals pi r squared. From there, we now take the derivative, implicitly with respect to time. So the derivative of area is dA dt equals, apply the power rule here, 2 pi r dr dt. And now we simply plug in what we know and solve for what we don't know. dA dt, we don't know that. 2 pi, our radius is 12. Our change in radius with respect to time is 2. So the change in area with respect to time is 2 times pi times 12 times 2. That's 48 pi square inches per minute, or square centimeters per minute. And if you want to go a little bit further, we can calculate 48 pi out. Pi is approximately 150.796 square centimeters per minute. For the AP exam, we want exact or rounded to 3 decimal places, rounded or truncated. All right. This is an old AP question we're going to look at. All right. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a constant rate of 200 or 2,000 cubic centimeters per minute. The oil slick takes the form of a right circular cylinder with both its radius and height changing with time. Note, the volume of a right circular cylinder with radius r and height h is given by v equals pi r squared h. That's what's nice about the AP exam. They're not testing your memorization of formulas, so they usually give you all those formulas. At the instant, when the radius of the oil slick is 100 centimeters and the height is 0.5 centimeters, the radius is increasing at a rate of 2.5 centimeters. At this instant, what is the rate of change of height of the oil slick with respect to time in centimeters per minute? All right. First off, let me cover up all this stuff that we're not going to look at. All right. So write what we know and write what we don't know. Or write what we're looking for. We know that the volume is increasing at 2,000 cubic centimeters per minute. So that is the change in volume with respect to time is 2,000. All right. We know that at one point in time, the radius is 100 centimeters. So R is 100. The height is 0.5. And the radius is increasing at a rate of 2.5. So that's our dr dt. The only thing we don't know is the rate of change of height. So that's what we're looking for. How fast is the height growing? dH dt. Okay? If you wanted, you can draw a picture, a right circular cylinder. That's the approximate shape of the oil spill. So our equation, they give us pi r squared h, and now we need to take the derivative of that. So what we'll do is we'll take a look. We see that this is a power rule problem, pi r squared, or not power rule, product rule. This is a product rule problem because you're multiplying there. So as we take the derivative, it's going to be dv dt, derivative, first function, pi r squared, times the derivative of the second, dh dt, plus the second function, times the derivative of the first, 2 pi r dr dt. And now we're at the point where we can plug in what we know and what we don't know and hopefully solve for what we don't know. dv dt is 2,000. Pi r squared, r is 100, so that's 10,000 when you square it. Pi dh dt is what we're looking for. Plus h is 0.5. R is 100, so that's 50 times 2 is 100 pi. dr dt is 2.5. All right. Solving for dh dt, we'll subtract 250 pi when we multiply 2.5 times 100. And we'll divide by 10,000 pi. All right, so that's the rate of change of the height with respect to time, which, if we take a look at it, 2,000 minus 250 pi divided by 10,000 pi make sure you group your 10,000 pi because you want your fraction to divide that entirely. And we can see we're changing, excuse me, at a rate of the height is increasing at a rate of 0.038 or 39 centimeters per minute. All right. Now, one more AP problem from the past we're going to take a look at. We'll probably just go through A and B, depending on how long it takes. As shown in the figure above, water is draining from a conical tank with height 12 and diameter 8 into a cylindrical tank that has a base with area 400 pi square feet. The depth h is changing at a rate of h minus 12 feet per minute. Write an expression for the volume of the tank as a function of h. All right? Volume equals, okay, the conical tank, so that's 1/3 pi r squared h. They say as a function of h. So we want to get rid of the r and replace it with h. So if we take a look at this diagram we have up here, let's bring that down so you can see it a little bit better. All right, we can see that when the radius is 4, the height is 12. So we can set up the ratio and solve it for r so that we can substitute r in and get rid of it and have just an h. Multiply both sides by 4. That leads us to say that r equals 4 over 12h, which can reduce to 1/3 h. So r is 1/3 h. If we plug that in, volume equals 1/3 pi times 1/3 h squared times h. Can clean that up a little bit. 1/3 times 1/3 squared is 1/27 pi h cubed over 27. So that's the volume as a function of h. Volume equals pi h cubed over 27. So we look at part B. At what rate is the volume of the water in the conical tank changing when h equals 3? So if we go back, we get our equation. Volume equals pi h cubed over 27. I'm going to write it like that so I can treat pi over 27 as a constant. At what rate is the volume changing? Well, let's do dv dt equals 3 times pi over 27 is pi over 9 h squared dh dt. We take our derivative. Let's plug in what we know. The depth of the water in the cone is changing at a rate of h minus t, h minus 12. So dh dt equals h minus 12. At what rate is the volume changing when h equals 3? So plug in what we know. H equals 3. We're looking for the change of volume with respect to time. So dv dt equals pi over 9. H is 3, so h squared is 9. dh dt is h minus 12. H is 3, so 3 minus 12 is negative 9. So as we work on this, the 9's cancel. It's negative 9 pi cubic feet per minute. Or, if you like, exact answers, or not exact answers, estimated answers. Negative 9 pi, negative 28.274. Alright. And then again, make sure you get your units, cubic feet per minute. So that is how fast the height is changing. I'm going to hold off on part C. We'll do that together in class on Wednesday.